Okay, we're going to talk about how cable loss influences the VSWR, the voltage standing wave ratio of antennas. So imagine this, I have an antenna I want to sell you. Here's my antenna, and I've got some cable, and I measure the VSWR, the voltage standing wave ratio, to be 1.5 to 1. So if you know about voltage standing wave ratio, you think, oh, that's not bad, it's pretty good. If I do a little calculation, you can press pause if you want to follow this along, but if the VSWR is 1.5, that means that only 6.25% of the power delivered to that is reflected. So that doesn't seem bad, right? So if I have an antenna and I deliver a certain amount of power, only 6.25% is reflected. So that sounds pretty good. Okay, so I look at this and I say, oh, I feed power in here and only 6.25% is reflected. 6.25% of power is reflected. Where? Let's say from there. So if you feed power in there, 6.25% is reflected. So does that mean that 100 minus 6.25% is radiated? Oh. And the problem is because, sure, if you feed power into here, 6.25% is reflected, but what's happening to the rest of it? The manufacturers who make their measurements from here, they want you to think that the part that isn't reflected is radiated out by the antenna, but a lot of it is eaten up by the loss of the cable. Okay, so that's the situation. So consider this. We have 1.5 to 1 VSWR here measured. So that means the power, and if the cable loss is 3 dB. So if you have a cable with a loss of 3 dB, it means you feed power in here. The power that ends up getting over here is half of the original power. Okay, so imagine this. So the power that you put into the cable is 100 watts. If you measured this VSWR to be 1.5 to 1, and you know that the 6.25% is reflected, then you know if 100 watts goes in here, the amount that comes back is 6.25 watts. Alright, so look at that. 100 watts this way, 6.25 watts that way. Then, of this 100 watts, how much gets here? It's 3 dB lost cable. That means half the power gets here, so 50 watts ends up into the antenna. And some other amount goes back, and that goes through 3 dB loss again to here. So you start with 100, half of it gets here, some of it gets reflected. Of this amount, half of it ends up here. So since there's 3 dB loss of the cable, if this is 6.25, this must be, what is it, 12.5 watts, like that. So now here we have reflected over forward power is equal to 12.5 over 50. Alright, so what is that? Let me get my calculator here. I see. 12.5 divided by 50, that's 0.25, okay? 0.25. So I can use a formula to figure out VSWR, and let's do that. VSWR equals 1 plus the root of reflected over forward power, 1 minus, I can do that. So that would be 1 plus the root of 0.25 over 1 minus the root of 0.25, like that. And then I can figure out what the VSWR over here will be. So let's try that. Well, here, 1.25. So 0.25, where's my square root? Oh, square root of 0.25 is 0.5. Alright, so this is equal to 1 plus 0.5 over 1 minus 0.5, which is 1.5 over 0.5, which is 3. So that means VSWR is 1.5 here, but VSWR is equal to 3 here. So if I go back to my original antenna, I measured 1.5 to 1 VSWR here, and it says that 6.25% of the power is reflected here, but at the antenna itself it has a VSWR of 3, and the percentage of power reflected was not as low as this. What was it? It was half the power was reflected. Ah, see that? So it looks like 6.25% is reflected, but in reality a lot more than that is reflected. So what I can say is, if the transmission line has loss, VSWR at antenna is always bigger or worse than VSWR at other end of the cable.